HVAC School and the HVAC School Podcast is made possible by generous support from Carrier. Carrier has shown their support for technicians and contractors since 1915, and Carrier is stepping up to the plate once again to support the men and women who actually do the work every single day. It says a lot to me when a manufacturer is willing to spend a little bit of time and resources to focus on training, and I really do appreciate it. Carrier, turn to the experts. I also wanted to let you know about TruTechTools.com. That's TRU TechTools.com. They're not technically a sponsor at this point, but we are working with them, partnering with them to give you a great offer on some tools. You can go to hvacrschool.com/TruTech and use the offer code GETSchooled at checkout. I recently bought a couple of Blue Vac vacuum micron gauges that were excellent. And also the old, let me pull this out here real quick. Cooper makes a great line clamp that also has a probe on it that I like just as a backup temp clamp. So you can check that out, hvacrschool.com/TruTech.
Stand to your feet, unless you're driving, and welcome the man who insists on wearing his duck knife on his belt, even though he hasn't actually cut a sheet of board since 2008. Brian Orr.
Thank you for that kind introduction, Joel Sharpton. And yes, it has probably been about since 2008 since I've cut duck board, but there's nothing better looking than a man sporting a gigantic knife on his side, other than a actually good-looking man doing the same thing. But I digress. Today, we have a good-looking man on the podcast, Stephen Reardon from HVAC with Stephen Reardon, the YouTube channel, I should say. That's HVAC with Stephen Reardon. If you don't follow Stephen on YouTube, I would suggest that you go do it. Stephen is a very thoughtful guy, and he's a real tech out there in the field every day doing videos of real tech type things. But today on the podcast, I wanted to talk to him a little bit about gas furnaces, and I've kind of been on a bit of a gas furnace kick. It's a weakness of mine. It's a strength of Stephen's. So here we go, Stephen Reardon. So thank you for taking the time to do this. I do appreciate it.
No problem.
I guess to start with, if you wouldn't mind, since you're a little bit of an HVAC celebrity, just sharing a little bit about how you started doing what you're doing now, specifically like how you started doing the YouTube channel and that kind of stuff.
No problem. My inspiration for YouTube was actually not related to heating and air conditioning at all. It was a guy that has been a staple in the YouTube community for the past 10 years or more, Philip DeFranco. I saw him doing his vlogs and his news stories and stuff, and I thought that would be really cool to have an audience and talk to them about whatever I wanted to talk about. And, it was attractive to think that you could do that and not have to go to work on a regular basis, but do that as work. And I created a channel back in 2006, I think it was. So it's been 10 years since my channel was started, but the couple of videos I posted up back then were really bad, and I never got any views, but mostly because I never really posted on a consistent basis. What really kicked me off was when I saw some videos from a couple of other YouTube staples in the HVAC world that were talking about the I-manifold system. And so I watched their videos and realized that suddenly HVAC actually had a pretty significant following on YouTube. And so I decided that I would respond with a video to the information that those guys were putting out. I took their videos and made another bad video just talking to my iPad. And I guess you could say I kind of picked apart their complaints about the I-manifold and gave my opinion of what at that point was simply the preview of a device that was going to come. It hadn't actually come out yet. And since I was the only positive voice out on the internet about the I-manifold, I got quite a bit of attention and people were talking and commenting on the video. When I heard about the I-manifold, I decided I would buy it. And so I bought it. I pre-ordered it through True Tech Tools and decided that when I started getting all this attention for the comments that I had made positive about iManifold, that I would go ahead and do a giveaway to get more attention, because I guess I'm a bit of an attention-grabbing maniac.
Yeah, you seem it. You seem really like high energy. You seem kind of like a techno sort of a guy, like a clubber, like you're into the clubs.
No, I do the electronic dance music, but I can't say that I'm a clubber by any stretch of the imagination.
That was meant to be sarcastic. As it turns out, I guess, so you are into EDM, so I guess I should have vetted my... I should have been more careful with my joke there, but anyway, keep going, sorry.
No, that's all right. I caught the sarcasm after I started responding, but I'm a little nervous talking to you.
Oh, really? Yeah, it's a pretty big deal. I'm sitting here in my only half-completed office, drinking a Miller High Life. So it's a pretty high gravity of what we're doing right now. This is very earth-shattering stuff.
Earth-shattering, absolutely. But yeah, that's pretty much where I've come from. I don't know that the story has to be finished in regards to how that all went, but iManifold was what got me launched into a consistent posting basis.
There seems to have been like a critical mass where a lot of people started doing things in social media and on YouTube specifically around, it's kind of surrounding the iManifold. It seems like Jim Bergman kind of inspired like a new generation of HVAC social media activity. Is that?
Oh, I would definitely say that seems to have made a lot of guys decide that they could probably start posting videos and talking about their day-to-day.
Yeah, it's interesting because I was introduced to you by Brandon Weiderhold. I think that's how you say his name. I hope I didn't say that wrong. And so I started watching some of your videos, and it's really interesting because, probably 6 or 7 years ago, I went to YouTube looking for content. And the only person who I found at that time who really, and I'm sure there were a lot of guys, but I didn't find them. The only person I found at that time was a guy who calls himself Dr. Zarkloff. I don't even know what his name is, but I found him and watched some of his videos. Some of them were humorous or whatever, but there wasn't a whole lot of really good information online. But now you're really starting to see it explode. Yeah,
Dr. Z was one of the first people that I watched more recently, but when I realized that there was a actual following or a community on the internet about HVAC, I went around and just sucked down data like crazy, watching all kinds of videos from different guys.
Cool. So I could talk about this all day, but I guess we should get into something that will actually help somebody.
Absolutely.
Just to I've kind of revealed this to you before, I think, or at least spoken about this on the podcast. We talked once before, and I don't know if I mentioned this, but I'm really a one-trick pony. Like in Florida, we do what we do, and we do a lot of it, but there's certain things that are just enormous gaps, and one of those enormous gaps is high-efficiency furnaces. Like I've never worked on a high-efficiency furnace. They're just non-existent in this marketplace. I mean, furnaces, period, are very rare. We do, probably 5% of the systems we work on, maybe even less, are furnaces, but they're all 80%.
Yeah.
Nobody down here, I've literally, other than the ones I've played with, I've never seen a technician with a combustion analyzer, much to my shame. So I'm really about as green as you can get. I understand the theory and the sequence of operation and, gas pressures and that kind of thing. But when it comes to really, dialing in especially a high efficiency furnace, but really any furnace, really being detailed about the analysis, I'm a total noob. So I was hoping that you could kind of treat me as such and talk down to me and kind of give an introduction to what you're looking for when you look at a furnace and how you look at combustion analysis.
Well, I will have to preface all of this with a admission that I am a novice in reality, but I guess the fact that I do it at all puts me in a position to maybe share my ignorance. But a lot of things that you look at on an air conditioning system, we can talk parallels with when it comes to combustion. You can get an idea of how well an air conditioner is running without actually checking superheat and subcool, correct? Refrigerant pressures. So when you look at a gas furnace, you can get a good idea of how well that furnace is running without actually checking combustion. But you can't say definitively that system is actually running within specific parameters. And the same is correct for air conditioning units, because without refrigerant pressures and superheat and subcool, you're guessing at how well that system's running. You may have a temperature split, you may have sweat on the suction line, you may have condensation coming out of the drain line, but you still don't know exactly how it's running. You're taking an educated guess at how well it's performing. So you add superheat and subcool to refrigerant, and you suddenly have details. You know exactly what the system's doing. And combustion is very similar to that, if not identical in concept. Generally speaking, you want to get a gas furnace between an arbitrary 6 and 9% oxygen and carbon dioxide. Carbon monoxide, as far as the output gas, is actually something that tells you a totally different story about the system. But if you were going to compare, once again, superheat and subcool, you would talk about your O2 and your CO2 as your superheat and subcool. If you were going to draw a parallel between air conditioning further, your stack temperature would be your airflow, or static pressure, if you will. You could also combine your draft on the vent pipe along with the stack temperature and compare it to static pressure. That is your general basic comparison to something that you would be familiar with. I'm trying to draw further parallels between refrigerant and combustion, but I don't know that I need to specifically. You're going to be looking at the gas pressure, which is one of the things that you're going to adjust to try to get your oxygen and carbon dioxide into the range that you want it. And then you're looking at actual airflow on the system as well, because that is partly where your stack temperature is affected. If the system is moving enough air to pull the heat off of the heat exchanger and heat the air properly. If you run across a system that has an exorbitant or an extreme stack temperature, typically you're going to start looking at things related to air movement. When I set up to do a system check, I set up all of my instruments all at once, and then I start the system, because I don't want to be looking at one thing that can be affected by another and not have any idea what the other parameters are, and then suddenly have to throw on another static pressure meter or air temperature meter to be able to realize where my other things are that could affect my combustion performance.
Got it. So what are those things? Like, would you mind enumerating, like, what is the full range of, if you were going to totally Mac Daddy test out a furnace, what all would you have connected at once?
Currently, I have a whole collection of things that I carry in when I get started, and it looks kind of excessive to a lot of people, and I've had several people that have said you need to find a way to streamline that. But I'm taking in 2 gas pressure meters so that I can check both inlet and outlet gas pressure at the same time. I've got 2 electrical meters so that I can check my flame signal while I'm also checking amps and volts of different components, because while I'm checking the flame signal with 1 meter, I'm also going to be checking the capacitor while it's running to see how that capacitor performs under a workload.
Right.
Then I'm a big proponent of the iManifold, so I use that for my temperature difference, and I use the iManifold dual port manometer to check my static pressure on the furnace while it's running. And then while I'm doing all of that, the system's warming up and I'm letting it run, I've got my combustion analyzer on the vent pipe, and I'm running that at the same time. And then as all of that is running, I take my meter clocking feature in the iManifold app and go outside after the system has stabilized a bit and I will clock my meter, which was another part of what you had mentioned you wanted to talk about. When it comes to meter clocking, I'm even more of a novice. I was taught an old calculation almost 10 years ago that I promptly forgot the first cooling season after I had learned it. But it was a generic number constant that would allow you to clock how many seconds it took to make a revolution on whether it was your half-inch gas dial on your gas meter or your 2-foot dial. And then you did a bit of a calculation with that constant that I don't recall, and it would give you an idea of what your BTU input of the system was. I've, like I said, since forgotten what that calculation was, and for the longest time I didn't bother clocking meters until I got into combustion analysis, because I fell into the concept that a lot of old school guys have, that what difference does it make? It's going to be running however it's running, as long as the customer's getting hot air out of the registers. You don't need to know how many BTUs the system's dumping. And I've come away from that in the past couple of years and almost violently disagree with that mentality. I'd rather know every detail of the system, however uninterested the customer is in knowing about it. I want to know.
And when you say violently, I mean, so have you ever, say, punched a guy from Florida who questions the exact reason why you would? Just hypothetically speaking, I'm just wondering how violent this actually gets.
No, I'm not actually a violent person. I have more of a passive-aggressive method to me.
Okay. So you would just passive-aggressive the heck out of me if I question the viability of clocking a meter. Yeah, I mean, I to me, like, clocking a meter seems like the equivalent of like doing a delta H on an air conditioner. You know, where you're confirming the exact BTU output of an AC system, and there's validity in it. But I've never done that on every system. And it's for the exact reason that you said you used to cite, which is, what difference does it make if I can't necessarily affect the outcome? What am I going to do to affect that outcome and make it something different, especially when you have so many things in a system that are constants that you can't, I mean, unless you're going to, an example would be like, well, I'll give you a perfect example. So I had a guy yesterday comment on one of my articles, the article where I was talking about setting a charge. And he said that, well, all this means nothing unless you check your static pressure first, which I don't disagree that checking static pressure is super important. But, in Florida, for example, we have all of these flex duct systems, and they are what they are. And there's only certain things that you can affect to make them different, unless you want to be the company that's literally telling every customer they need to upgrade their duct system, which that makes me uncomfortable at a core level too. So I'm torn. I guess I would be interested in what your take is on that.
Right. I can certainly understand it, because we've got the same issue in North Carolina, where if you come across a standard reducing metal trunk line that is in rectangular duct hung from the floor joists in a basement, you might as well have won the lottery, because it's that rare. When I came up in the trade, I started in Ohio, and everything up there was a basement. And when you ran across the crawl space, it was one of those very strange things to come across. Why would anybody ever lay an air conditioner on its side and not hang ductwork in a basement, 1 inch off the floor for supply and no inches for return to trunk line? But my interest in that information is that I've turned into a bit of an information junkie. As I've progressed through my almost 17 years now, I think it is, I have added to the information that I try to collect when it comes to a service or maintenance visit. I started out, like so many people, with a set of gauges, no temperature clamp, and I always called my senior techs wondering where my pressure should be. Right. And I think that's what aggregated the whole complaint about people just charging to pressures, because I've had people call me asking me what my pressures should be or what their pressures should be. And it's a lot easier when you're busy on a service call and you got a junior guy calling you up trying to figure out what's going on. to say, what's the indoor temperature, what's the outdoor, and just come up with a ballpark pressure system rather than trying to convince him that he needs to get his clamp meter out and temperature sensor and hook it all up and try to educate him on the fly as to actually checking superheat and subcool. But I'm getting away from my track. What was the question again?
The question was basically, I feel inferior and I want you to validate me. That was basically what the question was. No, just the idea of, I guess maybe in some ways I have an owner's mind because I'm both a technician and an owner. And as an owner, I just think to myself, oh my gosh, if all of my technicians have to have, $5,000 worth of diagnostic equipment alone, and they're going to take this much time, what's the thing that results a benefit to the customer from doing all of these additional things? And I mean, in one sense, I'm with you. I'm a total nerd for the trade, and so I like to know all this stuff. It's valuable.
Right.
And, I'm somewhere down the line because obviously I require superheat, subcool, checking external static pressure, that type of stuff. But when you go to I'm not having my guys check, I'm not having them check Delta H on every system, and then they're not doing combustion analysis on every system even, but that's just because it's so rare. Although I am going to start doing that now because now I feel convicted.
Well, good.
Yeah, so
let
me
at least
accomplish that.
Get to my thought before I lose it again.
Okay.
And I'm losing it again. The importance of clocking the meter is an opportunity to sell additional service work as an option. When you go into a house, you're interested in air quality, you're interested in humidity level. At least up north, it's typically more because you got gas heaters. Down south, maybe humidifiers aren't that much of a market, but any information you collect gives you more of an opportunity to sell accessories or additional services. If you pull the filter off the wall and you look behind it, you have an opportunity to possibly sell duct cleaning. If you check the relative humidity inside the house while you're there adjusting the thermostat, you have an opportunity to either sell dehumidifiers, which would be weird if your air conditioner is actually working properly, or humidifiers to add humidity to the house in the wintertime. You're asking about allergies, you're asking about issues with health, because you're looking to sell high-grade filtration and ultraviolet light. If you go to a system and you check the gas pressure, you check the temperature rise, and let's say you're actually doing combustion. Today I checked a system that had oxygen within range, carbon dioxide within range, and my stack temperature was actually quite high compared to where it should be. Generally speaking, an 80% furnace, you're going to see it somewhere around 300, 350 in that ballpark. And my stack temperature was almost 425 degrees. My temperature split was also excessive, but with the fact that I had oxygen and carbon dioxide within range, if I had not clocked the meter, I would not have realized that the system was actually underfired for the BTU rating. And if I was looking at that system as an opportunity to sell additional service, I would be telling the customer this system is not running anywhere near its rated capacity. You've got duct problems because you have an excessive temperature rise, and we can make that system run where it was designed to if we offer the customer the option of increasing the orifice size so that it's actually consuming gas at the rate that it was designed to. Does that make sense?
Yeah, no, I get it. I mean, it's like, to go back to your initial metaphor, there's lots of things that you wouldn't know by just checking your pressures, say, where your pressures could look normal, but you could have offsetting circumstances, so you could have, what would an example be? An example could be that you have a suction pressure that looks normal, but it could be normal because you have a piston that's too large in the system and an undercharged system. You're not going to know that unless you're actually checking your subcool to see that you have zero subcool.
Correct.
Yeah, so that would be, to me, an equivalency, and I guess, I can see that, because with what we're checking, which is essentially just, we'll check temperature rise, we'll check gas pressure, but we're not really going to know. We're going to look at the flame. We're not really going to know if you have a system that has a significant capacity issue. We're not going to know that.
Right. I did a system, and I did a video on it maybe a little over a year ago, and it was a system that I had checked for my wife's boss. And he had another company out there that told him that his 10-year-old top-of-the-line Trane variable speed gas furnace, 10 years ago, it was the most expensive system that you could get for residential Trane furnace. So it's the equivalent to today's XV variable speed compressor and all that. They told him that he needed to buy a new inducer motor for this furnace, and it was going to cost him $1,100 for the inducer motor, which doesn't surprise me. A variable speed inducer motor is something like R22. It's extremely expensive. Mm-hmm. But as the system was the top-of-the-line unit 10 years ago, he felt like he shouldn't be looking at a $1,200 repair only 10 years after the system was installed. So he was simply looking for a second opinion. Mm-hmm. I went over there and checked the system, and before I even got to combustion, I checked my gas pressure, and it was rated at a 3.5 inches of water column, and the system was running 4.5 inches of gas pressure. And that in and of itself would be something I would adjust, even if I wasn't looking at combustion or clocking the meter. But by looking at the meter and clocking it at 4.5 inches, I found out that they had done that on purpose to get the rated BTU input out of the system, without realizing that by jacking the gas pressure a whole inch over the designed pressure setting, that they were going to change the shape of the flame going into the heat exchanger and potentially impinge on the heat exchanger because the pressure was so exorbitantly high. And by lowering the gas pressure back down to 3.5 inches and clocking the meter again, it showed me that those orifices were undersized for that particular application. And it's what the factory sent in that unit. So without checking the clocking of the meter, I would have just taken it back down to 3.5 inches of gas pressure and never thought anything of it.
Yeah, there's almost like the quality to that level of diagnosis that's almost deconstructing the engineering. Like where you're not just questioning, things that could have happened in the field conditions, in the field setup of it, but you're actually able to then say, hey, Trane, you actually sent the wrong orifice size in this brand new top-of-the-line furnace, which is an interesting, way of looking at it. But it just happens so rarely that it's hard, for the average technician, the non-Stephen Reardon level technician, to even, I think, consider.
Right. If I was going to make a recommendation to a junior technician, I'm not going to probably force him to buy $1,500 to $3,000 combustion analyzer. I'm not even going to have him buy the iManifold system, because you can do everything that the iManifold does without it. Zach Ciota of the Working Joe's Roundtable website is a big proponent of not using tech and learning the basics. I'm on the flip side, but I understand his perspective. And if I was going to be helping a young technician get into gas heat, I would drill into him the way to clock a gas meter, check the temperature split, check gas pressure, confirm static pressure, and those would be the basics that I would start him out on. I would not put him in a combustion analyzer because, that is a little bit of an investment to make as a maybe 6 month to 1.5 year technician on $15 an hour. That can be kind of painful.
Mm-hmm. That's what I still make. Is that a problem?
No, I'm just saying.
Okay.
If I counted my income from YouTube as my only job, I'd be making next to $1 an hour, maybe.
Right. Yeah, that's how that always works. Okay, so I guess just quickly, if you can summarize, so CO is the wicked witch of the West, the thing that nobody wants to see. I mean, so what are some of the things, if you see a system that's running high carbon monoxide, what does that mean to you? What are you looking for?
A lot of times carbon monoxide is going to be something that is related to the cleanliness of the burner itself. It is not pushing gas through the burner and mixing with the oxygen quite like it should restrictions a lot of times will be part of why you have carbon monoxide issues, but most of the time it's due to improper adjustment of gas pressure. I've had several systems in the past week or two where the way they were firing when I walked up to them was pretty close to the 6 and 9% O2 CO2, but by making those numbers a little closer or dropping them into the range of 6 to 9%, I was actually able to get my CO to completely disappear. Where I may have had 10 or 15 CO with it at 10.5% oxygen and 5.9% CO2, by increasing the gas pressure a little bit, I was able to drop my 10.5 down to 9, and my 5.9 came up to, say, 6.8, and my carbon monoxide went away completely. One I looked at today actually had an obstruction in the little vent hood on a package unit. A piece of insulation had peeled off of somewhere and somehow got behind the screen in the vent hood, and that system had that type of a restriction for however long, but it was so long that it put heavy soot coating on the inside of the vent pipe, inducer motor, and heat exchanger. And I had over 12,000 parts per million carbon monoxide. And that's at least, 11,600 over the safe limit.
Right. Yeah, enough that your analyzer's probably like, get me the heck out of here before you damage my sensor.
Typically, I wouldn't leave my sensor that long. I would have pulled it at about 2,500, but I was curious to see how the Testo 330 did with the automatic dilution feature.
The good old automatic dilution feature. That's my favorite one of all of the features on the Testo 330. I'm just trying to be cool and act like I know what I'm talking. I'm just trying to be one of the cool kids and act like I know what I'm talking about. I mean, I appreciate it.
You're welcome. Thank you.
Yep. Have a nice evening.
You too.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.